Welcome back for another little optional piece, again totally optional. I just wanted to tell you about another way that I do UART communication that I find useful, and I wanted to show you some example code. So really it's not much of a lecture, it's more of a demo of something you could do if you ever need to do that next step up of slightly more complex communication. So what we're going to do is we're going to show you how you can communicate just with simple strings, right? So literally if you wanted to say to start a motor, you would just send the message start. So you just say start. So it's actually 6 bytes. And the first thing everybody says is, oh, that's got to be so inefficient, it sends 6 bytes. Keep in mind that even at the slowest speed, that only takes 6 milliseconds, right? So it's still, as far as humans are concerned, extremely fast. It's also nice because if you just send it, let's say you have to send a reading, so let's just say, you wanted to send back RA0, you could just send back, 532. And it can be really easy just to send strings over the line. And then you have this system where all messages end with a \n. It's just a way of saying, hey, here's the end of the message. So I was just going to show you how to do this real quick. So what I want to do for this is I just want to make a new project. And so we're going to just make a new project, but then we're not going to write any code. We're going to download some code. So I'm going to say recently used. I'm going to use my pit kit that's connected. And I'm going to call it string communication. And so the only reason I wanted to do this is because then it gives me a place to put this downloaded file. So there should be a .c file in the code above. So you can right-click on that link. What I'm going to do is I'm going to right-click on this link here and say Save Link As. And then navigate to wherever your project folder is that you just made. So you should have a string communication.x folder, and then just save it right into there. And then in MPLab, what you can say is add existing item. So this is kind of like what you've done in labs, and you can select that .c file. So this .c file, what it does is, I just want to kind of show it to you here, is if you scroll down to the bottom where you receive things, essentially the only thing it changed is the do something with byte area. So before, in the last video lecture, we just printed it to the screen. Here what we're doing is one of two things. If it is the message terminator, so if it is a \n, then do one thing. If it's not a \n, you just save it, right? So just save it, do nothing else with it. And so there's some code in here just to save it into a temporary RX buffer. If it is the terminator, then what we want to do is we want to say, hey, there's a new message available. So we want to, this line here, we want to say, hey, there's a new message available. And we actually copy over that temporary buffer into another buffer. So if you wanted to do something like this, you could just copy this code directly. You don't really need to understand it even. I've got a couple helper methods for copying and clearing buffers. The real meat is in the main file. So in the main file, what we've got is we've essentially got a place where we're checking, this is like a main event flag. So if there is a new message available, then say set it to 0. And so what we want to do here is we want to see what message it was. So in order to see what message it was, one way you can do it is you can use what's called a string compare. And you can say, if it was the start command, so start command is up here. So you just have to define a start command, and then if it was a start command, then do this. So what you could do is you could choose to add your own command. Let's just add our own command here. Let's just say char, we'll just call it my command. And we'll just make this command, I don't know, all LEDs on, right? I'll choose to, casing is important, right? So if I ever see the command all LEDs on, then I'm going to process that command. So I'll come down in here and say, now I've got one more. So Control C, if the string compare is equal to my command, then I want to turn all the LCDs on. So I'm just going to say port C equals 0xFF. It won't turn on tris C0, but that's okay. So that's something that we want to do. I'm going to go ahead and make another button here to send it. So if, let's say, RB1 is pressed, then we'll send all LEDs on. Casing is important, so I can check to make sure it's the same up here. Looks good. All right, and so now I can run this guy. So I'll just go ahead and hold the board up here. So if I press, what was it, RA4, that turns on, that sends the start message, and the start, all it does is it just turns on this one LED. If I press RB0, it turns it off. So you can see those guys are getting sent. And then if my new command works, whenever I press, what is it, RB1, all the LEDs will come on. I'm not sure if this will work or not. It'll be fun. All right, pressing RC1 or RB1. Yay, they all come on. If I wanted to turn it off, I can press RB0. So this is just a demo of one mechanism for doing like a more complex communication protocol. In the lab, we're going to do something entirely different, but I just kind of wanted to show you this is a technique that I use a lot, right? So just doing communication really simply of sending strings that have \n at the ends, and then the other end can choose to parse it how you wanted. I could also make this talk to SecureCRT, and I could send messages from there as well. And it's just kind of a neat system. So some people might need this, so I just wanted to give you the sample code. That's it. All right, the end of UART communication. I hope you enjoy the lab where you actually do some of this stuff. See you next time. Bye.